Hey everyone, today we'll be solving LeetCode problem number 231, power of 2. In this problem, we will be given an integer n and we have to check whether it is a power of 2 or not. If it's power of 2, returning true, otherwise we will return false. They have also given the definition. An integer n is a power of 2 if it can be written in the form of this. N equal to 2 raised power x. If this expression is true, we are going to return true, otherwise returning false. I hope the problem statement is clear to you. So how we are going to achieve it? So the first brute force coming to my mind is like checking all the power of 2. That is, what is the what is the zeroth power of 2? That is 1. 2 to the power 1 is 2. 2 to the power 2 is equal to 4. 2 to the power 3 is equal to 8. And so on. And let's say if at any moment 2 to the power x is equal to n. We have got the answer. Or let's say 2 to the power x minus 1 is less than n. So we will move 1 unit ahead. Now 2 to the power x is greater than n. It means we have not found the answer. This is not a power of 2. So we got the idea that we will be checking all the power of 2. If 2 to the power is equal to n and 2 to the power 1 is equal to n, and we will keep on incrementing the powers until it becomes equal to n or it is exceeding the n. If it is equal to n, we are going to return true. If it is exceeding the n, we are going to return false. So I hope that is clear to you. And what is going to be the time in this case? Here the expression is n equal to 2 raised power x, and if I take a log of both sides, log n is equal to log 2 raised power x. X will come to the front. So log 2 by 2 is 1. So x is equal to log of n, and x is what? X is the number of operation we have taken. So first is 0th power, 1st power, second power, third power. So x is the number of operation we took. So these number of operation are equal to log of n. So the time complexity will be order of log of n, and no space we are taking. So this is the time complexity if we have to check whether it's a power of 2 or not. But we are also given a follow-up question. Could you do it without using loops or recursion? It means we did this using loop, and we can also do it using recursion. So in the recursion, we will keep on reducing n. First it is n. If n is divisible by 2 equal to 0, we will reduce the problem to n by 2. Whether n by 2 is a power of 2. If n by 2 is also even, we will reduce it to n by 4. Whether n by 4 is a power of 2. So we will keep on reducing it until n is becoming equal to 1. That is 2 raised power 0. And we can return that there is no more 2 can be accommodated to this n value, and it is a true value. Okay, so this was the brute force checking all the possibilities of 2. So how we are going to achieve it without using loop and recursion? In this case, we are going to be using bit manipulation. As this n is having a power of 2, it means its binary form should be something like this: 1 0 0 0 0, like this, or you can say 1 0 or 1 0 0. Let me make it more clear to you. It is 2 raised power x. So all the power of 2, if I write in the binary form, 2 raised power 0 is nothing, 1. 2 raised power 1 is 1 0. 2 raised power 2 is 1 0 0. 2 raised power 3 is 1 0 0. And 2 raised power x is equal to 1 x times 0. Okay, so we have got the idea that if it is a power of 2, its binary form should have only one set bit. Now our problem statement has reduced to the problem that we are given a binary number and we have to check whether it is having only one set bit or not, or it is in the form of this or not. So for this, how do we check? Now we have to check the number of set bit. If number of set bit is equal to 1, return true, otherwise return false. So we just have to got the idea like how do we check the number of set bit. Here what is the least possible value of a 2 raised power something? That is 2 raised power 0, which is 1. And 2 raised power 2 is 100. 2 raised power 3 is 1000. Something like this. So if we keep on reducing one power at one step, let's say from 2 raised power x, we reduce it to 2 raised power x minus 1, then 2 raised power x minus 2, or you can say 2 raised power 4, we have 2 raised power 3, then 2 raised power 2, then 2 raised power 1. If 2 raised power 1 is equal to 1, it means this is really a power of 2. If we keep on reducing one power from this 2 raised power x, or you can say n, and in the end it is becoming 2 raised power 0, that is 1, it means this was really a power of 2. This was the main idea behind this problem. So let's say our n is 2 raised power x, and what we are going to do is we will just keep on reducing this 2 raised power x to 2 raised power 0. So first of all, it was 2 raised power x, and we will be right shifting it to 1. When till when we will be right shifting it to 1? If it is in the form of like this 1000, that is n is greater than 0. It means if n is greater than 0 and n and 1 is equal to 0, it means we have 0 in the rightmost, rightmost digit. What I'm going to do is I'm shifting this 1 to rightmost significant bit. So if n is greater than 0 and n and 1 is equal to 0, that is on the right side it is 0, we can just directly do the right shift by 1. While n is greater than 0 and the rightmost significant bit is 0, we will just do the right shift. It means we are shifting the bits to the right side until this one bit is coming to the rightmost bit. So initially it was 100. I'm shifting it to 100. That is right shift by 1, and then shifting it to one more right side, right shift by 1. Then again it is greater than 0. Then again shifting it to one unit on the right. I shifted by 1. If at any moment it is becoming equal to 1, that is the rightmost bit is not 0. So we don't have to check further. If it is equal to 1, it means that answer is true. If it was something like this, 11000, 1100, 110, then 11. If at any moment this moment it is getting 11, that is 3 instead of 1. If it is not equal to 1, we are going to return like false. So how do I write the code in this case? First of all, let's say this is function and we are given n. We are given n as an input and we have to return boolean. What I'm going to do is while n is greater than 0 and n and 1 is equal to 0. That is, we have 0 in the rightmost bit. If it is a 0 in the rightmost bit, if it is greater than 0, we will do the right shift by 1. So this is a step 1. And what is the step 2? That we have reduced all the right 0 which are on the right side. That is, now the binary is in the form of 1 and these zeros we have reduced. So it can be 1 here or it can be 0 here. We don't know. So now at this moment, if it is equal to 1, we are damn sure that there was only one set bit. So what we are going to do is I'm going to return n equal to 1. If it is 1 after reducing all the zeros, it means that it is in the form of like this 2 raised power x. Otherwise it's not a 2 raised power x, 2 raised power x plus something like this. So these are the two steps for our problem. making this check to not going it to TLE. Let's say if the problem statement given is something like this, n equal to 0, and if we keep on doing this forever, so we have to check first whether n is greater than 0 and n and 1 is equal to 0. In this case, we will just make the right shift. Otherwise, if we are not able to make the right shift, we will check whether the n is reduced to 1 or some other number. If it is reduced to 1, it means it's a power of 2. Otherwise, it's not a power of 2. Okay, I hope this problem statement is clear too. And what's the time and space complexity here? The time complexity is order of 32 because we have 32 bits, and at most we can make 32-bit operations. So we will consider it a constant time solution. So it's way better than log of n. So we are solving it in a constant time. Okay, I hope you understood the problem. Let's start writing the code for this problem. Here we have to check whether n is something like this, 1 triple 1 0 0 in the binary form, or if it is something like this, 1 0 1 0 0 0. So if it is in the first form, it is definitely a power of 2. In the second form, it's not a power of 2. Now first of all, we have to remove all of these zeros. If it is a 0, remove it, make a right shift. So for that, first of all, we have to check whether n is greater than 0. If it is not a greater than 0, so it is of no sense making a 0 a right shift. So n greater than 0 and n and 1 equal to 0. What is this condition? It means if I'm making an AND operation of this and the 1, that is on this rightmost bit, I will get to know whether it's a 0 or 1. So if it is a 0, just do the right shift and greater than equal to 1. So now we have reduced these values to something like this. Here I just have to check whether my remaining n is equal to 1 or not. So for that, I can directly return whether n equal to 1. If it is 1, it's a power of 2. If it is in this form, it's not a power of 2. Let me run over sample test cases. So on the sample test cases, it is working fine. Submitting the problem. It got submitted successfully. Hope you understood the problem. And we have also another method that if I take a n and n minus 1, what this operation is going to do? This operation is going to do remove rightmost set bit. So this operation is removing the rightmost set bit. If after removing the rightmost set bit, my number is becoming equal to 0, it means it was a power of 2. So if we remove the rightmost set bit from this number, from this 1 triple 0, it will become 4 times 0, or you can say directly 0. So let me write that solution as well for you. If n is greater than 0, n should be greater than 0, and n and n minus 1 equal to 0. It means if it is true, n taking AND with n minus 1 is equal to 0. It means there was only one rightmost set bit that we have removed, and after that it is becoming equal to 0. It means it was a power of 2. So we can directly return this expression. Return n greater than 0 and taking this AND value. Yeah. If taking a AND with n minus 1 is equal to 0, that is there was only one rightmost set bit that we have removed. After removing the rightmost set bit, if we are taking 0 as an answer, it means it's a power of 2. So let me run this problem. Okay, first of all I have to comment. Let me mark it old. I'm running this function, passing all the test cases. If I submitted the problem, it is also submitted successfully. Okay, thank you guys.